Kia ora, Year 11 and 12. This question is for Inesh, and it's a combinations and permutations one. It's from the booklet of Perms and Comms questions that I put on Google Classroom, but I wanted to go through the worked solutions. There are 4 questions in here, and the first 2 are pretty straightforward, but then the last 2 are ones where you have to think. Now, this third one I'm going to do in 2 different ways, and then in this fourth one I'm going to show you a way that I think is a little counterintuitive to start with, but quite a cool approach for harder problems. Okay, so the first one, Freddie has got 6 toy cars and 3 toy buses, and they're all different, and he's choosing 4 toys to take on holiday with him. So how many different ways are there for him to choose 4 toys? So in total, he's got 9 different toys, and he's got to choose 4. So if he chooses, I don't know, bus 1, bus 2, car 1 and car 2, that's going to be the same as choosing car 1, car 2, bus 1. In other words, the order doesn't matter. So all we're doing here is we're choosing 4 objects out of 9 objects. So that's why it's worth 1 mark, right? It's 9, choose 4, you can, or 9, that's a combination, not a permutation. You can chuck that into your calculator, or you can work it out by hand. So it's 9 factorial over 4 factorial, 5 factorial, and when you chug that through and cancel some things out, you'll get 126. Okay, out of those choices, how many of these choices will include both his favourite car and his favourite bus? So the way that I do these questions is I just draw a silly diagram that looks like this. So here's car, favourite bus, and then he's got 2 more things to choose. Okay, so he's got 7 toys left, and he's got to choose 2 of them. So that's 7 choose 2. There's only one way for him to get his favourite car and his favourite bus. So this question is going to be simply 7 choose 2 times 1, which works out to be 7 factorial over 2 factorial, 5 factorial, which is 21. Okay, now let's look at these next 2 that get a bit more interesting. So Freddie lines up his 9 toys, and we've got to figure out how many possible arrangements there are if the buses are all next to each other. And we've got to remember that his buses, the 3 buses he's got, are different. So again, I draw a diagram that looks like this. Think about the 3 buses together. So they have to be next to each other. And then there are 6 other toys. 2, 3, 4, 5, 6. So the buses could go in that first position, or they could go here, and so on. So there are 7 ways to arrange to choose this first number, 6 ways to choose the second, and so on. In other words, it's a classic arrangements setup. It's going to be 7 factorial. But there's one more thing we've got to think about. The 3 buses are different, and so their order matters. So bus 1, bus 2, bus 3 is not the same as bus 3, bus 1, and bus 2. And that means that we haven't just got 7 factorial ways to arrange everything. For each one of these, where we've got the buses in a particular position, we've got 3 factorial ways that we could be arranging those buses. So my answer here will be 7 factorial times 3 factorial, which is a massive 30,240 ways. And I bet none of you thought about that when you were 3 years old and you were lining up toy buses and toy cars or toy bits of Lego. Okay, so that's that one, right? So the key thing to think about in each of these is, does the order matter? Now this last one I think is a really cool question. We have to say how many arrangements there are if there's a car at the end of each line and there are no buses next to each other. And when I did my work solutions for this, Inesh, you asked me why I ended up using 11 places in my lineup when there are only 9 toys. Hopefully this is going to make a bit more sense when I go through it slowly. So we know that there has to be a car at the end of each line, at each end of the line, and that no buses are next to each other. So we've got a car here, and we've got a car here, right? And we've got 6 cars altogether. So 1, 2, 3, 4, 5, 6 cars there, and no buses next to each other. So that means that I can't have bus in here, right? So we'll get rid of that. I could have a bus in here, a bus in here, and a bus in here. That would mean that I had car, bus, car, bus, car, bus, car, car, car. Okay, so that's one thing that could happen. I could have a bus in here, and a bus in here, and a bus in here. And then I'd have car, car, bus, car, car, bus, car, bus, car. Hopefully you're starting to see where the 11 total things comes from, right? There's no problem with the cars being next to each other, but there is a problem with the buses being next to each other. So I can see 5 possible places to stick a bus. I can put a bus in here, a bus in here, a bus in here, or here, or here. But I'm only going to use 3 of those possible places. So I've got 5 gaps, and I want to stick in 3 things. And the order is going to matter, right? So bus 1, bus 3, bus 2 into these 3 gaps is not the same as bus 2, bus 1, bus 3. So that means I'm going to be thinking about a permutation, not a combination. So let's first of all think about how many ways there are to arrange the 6 cars. Right? Well, there are 6 factorial ways to arrange the 6 cars. And for each one of those, I've got to multiply it by the number of ways there are to choose where the buses are going to go, right? And so that's going to be 5p3. Or another way to think about that is 6 factorial times 5 times 4 times 3, right? I'm putting in 3 buses into 5 slots. Okay, so this method of looking at where I've got my gaps and how I can fill them up is a really good one. Remember, this is going to be a permutation because the order of those buses will matter. So my final answer here works out to be 43,200. So Inesh, I hope that helps. You're right that there are only 9 things, right? But setting it up with 5 possible gaps means that it does look like I'm working suddenly with a problem with 11 toys. But I'm not, because only 3 of those gaps are going to get filled up with a bus. So I've got 6 cars and I've got 3 buses that I've got to stick into those 5 gaps. Let me know, guys, if this still needs more work, and I'll try and come up with a couple more questions like it. Otherwise, good luck for the last day of revision, and I'm going to get a couple of last videos done now.